This is Richmond, and today's tutorial I'll be talking on Pythagorean triples. So, Pythagorean. Okay, I'm dealing with Pythagorean triples, and for the Pythagorean triple, all that we need to know is that if you have three integers, let's say a, b, and then c, if these are three integers, such that if the sum of square of two of them equal the square of the third integer, so if I get a square of, let's see, a plus the square of b, if it's able to give me the square of the third one, then this is all that we call the Pythagorean triples. So we have three different integers, but if you square the two into that a and b, the sum of the two should be equal to the square of the third integer. Okay, so we have a way of coming out with this particular theorem. So I want us to just start from the basis and then prove the Pythagorean triple. Okay, for us to prove the Pythagorean triple, we need to proofing the grand triple. Okay, so all that we need to do is that state that x plus 1 square minus x minus 1 all square. So we try and then expand this expression and you will get x plus 1. Let's simplify them in a simple way. X plus 1 minus, because the minus is affecting everything in the bracket, so we bring the square bracket outside, and then we multiply this one in the bracket like this. Okay, so expanding this one will get us x outside, and to multiply x plus 1 here plus 1 outside, we multiply everything in the bracket again, x plus 1. So the minus is outside here affecting everything, so we take x inside this bracket, we use it to multiply or operate it over the bracket here, which is x minus 1 like this. Okay, come and use the minus 1 inside this first bracket and we operate it over the x minus 1 like this. Okay, so let's try and then simplify this. Okay, by simplifying it, we can get something like this. X multiplied by x will give us s squared. X times 1 give us plus 1 plus x rather. Okay, and then we come here, 1 times x will give us x, and then 1 times 1 will give us plus 1. So let's maintain the negative outside there. So in a bracket, x multiplied by x will give us s squared like this. X multiplied by negative 1 will give us minus x like this. And then minus 1 minus x will give us minus 1 multiplied by x will give us minus x. And minus 1 multiplied by minus 1 will give us plus 1. So now we can multiply the bracket, multiply through by the negative here. So now we have something like this. Okay, x squared now plus 2x, because x plus x is 2x plus 1. And when you multiply negative through the bracket here, you're getting negative s squared here, and then plus, because negative, let's try, please add this one together, negative x, negative 2x. So negative 2x here multiplied by negative 1 give us plus 2x, like this. And then negative multiplied by 1 give us minus 1, like this. Okay, so let's break it down here. S squared and s squared, because negative positive x squared and then negative s squared, what they do that they'll cancel out. So this one will cancel this one, and then plus 1 and then minus 1, they'll cancel out. So now it left with only 4x, like this. So expanding everything will give us 4x. So mathematically, if I have x plus 1 square minus x minus 1 here all square, if this one is equal to 0, then I will have my x plus 1 all square is equal to x minus 1 all square. The negative change it to be positive. So it is mathematically sound to write x plus 1 square is the same as x minus 1 square plus 4x. Please, if you like, expand this one and then expand this one and see if you not get the same thing. You get the same thing. So x plus 1 square equal to x minus 1 square plus 4x. Okay. So here all that we need to do is here that let's divide both sides by 4. So we are dividing here by 4, here by 4, here by 4. So this one by 4, the whole of this one by 4, the whole of this one by 4. So I can write it this way, that 1 over 4 x plus 1 all square is equal to 1 over 4 x minus 1 all square plus x, like this. Okay. So at this point, I just want us to get some expression which will be the same as this. Okay. And so I can change this expression to 1 over 2 x plus 1 or multiply by 2, like this. And this expression is the same as this. You can just expand this one and expand this one and see if you not get the same thing, you get the same result. So this one is the same as this. So we can now say this is now equal to 1 over 2 x minus 1, and then with the bracket 2 here plus my x. Okay, so from this point we can jump straight, and we know that this is equal to this and this is equal to this now. So let's say that replace x. Let's replace x with k square, or we are substituting k square in the position of x. So now our equation now becomes half, and then I have my k square here, k square now plus 1 here, and then all square is equal to 1 over 2 here, and then I have my k square minus 1 here, and then 2, and then I have plus k square. The point is that I've just replaced the x with k square. And then here we are. So for us to get our Pythagorean triples, all that we need to do at this point is that let's replace k squared by an odd number which is greater than 1, and let's take 3. So replacing k squared by an odd number, or replacing k by an odd number greater than 1. So let's take the odd number. The odd number here to be equal to 3. So let's substitute k by 3. So we have half here, which is multiplying, and I have my 3 square plus 1 square is equal to, and this one will be 3 square minus 1, and then I have my 2 here plus my 3 square, like this. So all that we need to do here is simple. 3 square give me 9, and 9 plus 1 give me 10. So I have half, and then I have my 10 here. Square is equal to, here 9, 3 raised to 2 is 9 minus 1 will give me 8. So I have my 8 here, and then my square on top plus 3 square, like this. Okay, so 10 divided by 2 will give me 5. So I now have my 5 here, but square is on top, so ring the square is equal to, here 8 divided by 2 will give me 4. So 4 here, the square on top there, so bring it plus 3 square. So please, 5 square is 25, 4 square is 16, 3 square is 9. So you can see that when I sum the whole of this, it will be equal to this. So this is how we prove the Pythagorean triples. When I sum, the square of these two integers should be equal to the square of this one integer. So in the next tutorial, I'll be taking examples on Pythagorean triples and how to solve them. Thank you.